Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We're coming to you live from our massive Cloudcast studios here in Raleigh, North Carolina. And it is Aaron for the intro this week. We are full on into spring conference season. Lots of shows and events already happened and more on the horizon. I'm in work crunch mode preparing for upcoming events, and it's that time of the year I kind of hate, but I also kind of love all at the same time. Our topic for this week is the generation of synthetic data, but specifically around AI, but this also really applies to any application that needs testing data at scale. And that conversation is coming up right now.
And we're back. And Aaron, how you doing, man? Spring's in full bloom. How have you been so far?
I'm good. Yeah, I've kind of said it on once or twice on the shows before, but it definitely feels like spring. It's warming up. The spring conference season is here. Lots going on. It's been a pretty exciting spring, actually.
Yeah, no, it's been good. Now, you and I obviously have been talking a lot about the topic du jour, and one of the things I was thinking about recently is, as a data scientist or anybody who's managing teams of people that are trying to manage data, and their data may not necessarily be in the same place as their GPUs or the place where they're going to do acceleration and training and so forth. I got to thinking about that, especially for enterprises, and you think about just how restrictive companies are with the most simple things, like, what happens if you take your laptop on the road with you, right? There's a whole set of training that goes with, don't do this and don't lose the data. Or, what do I do with my cell phone? Like, what can I put on there? What can't I put on there? And then I think about the massive amounts of data that are involved with, whether it's fine tuning or training or even RAG with some of these AI environments. And you start to wonder, like, how are they going to deal with this, right? How are they going to deal with potentially moving their data outside of the four walls or in secure environments? And, we got to think about this, like, this would be a perfect opportunity if there was some way to create a representation of your data that the security teams would feel a little more confident with. And that would be probably an interesting topic for us to dig into.
Yep. And so our topic today is synthetic data. And of course, as we want to go and talk about that topic, we go and find somebody. And we have a fantastic guest for today. We have Kalyan, CEO and co-founder at Datacebo. First of all, welcome to the show.
Thank you, guys. Thank you.
Yes, absolutely. And so let's start at the start, because some may have heard about synthetic data, or they're already using it, but maybe they've not referred to it in that way before. But tell everyone a little bit about what is the use case and the need and the problem synthetic data is solving today.
Great, thank you. And I love the introduction. Brian just mentioned about laptop on the road, and I'll come back to that in a minute, because we actually had that situation when we founded this project. So synthetic data is sort of data generated from a generative model that is trained on the real data. So you train a generative model on the real data, a little bit of real data, and then you get a model. And from that model, you can generate synthetic data that looks like the real, has all the statistical properties and format like the real data, but cannot be linked to the real data. It's actually a sample that is generated from a model, which is a mathematical representation of the data. So one of the great things that it provides is an alternative when access to the real data is restricted, as we were talking about it, or needs to be restricted or is not available. So that's the immediate apparent need that enterprises have for this kind of data or for this kind of modeling technique. What is less known, however, is how dramatically it changes that data access and availability. So just to give you an example, like once you build a generative model, you can actually sample as much data as you want. So you're not limited by your original data sites. So you can sample 10 million records, 1 billion records of customers, even though you train probably the model only on just 10,000 customers' data. What that enables people right away is to create data for performance testing. I mean, that's just the day zero ROI that enterprises see with this kind of technology, where they can create a lot of data in their lower environments and not have to port the data or a large database, but just use this model that's usually very, very small, maybe a couple of gigabytes, even though your data could be terabytes, and sample from it like billions of records and test it for performance, your software application for performance. So that's just one kind of example for that particular sort of game-changing technology that this is, that it's used for. The other example is more involved and interesting. It's even more less known, but it's actually very powerful use case, which is it's known, generative models are known to have the ability to generate data for a particular scenario. So what you can do to this model is specify a particular scenario. So you can say, for example, an insurance company, if you're an insurance company, you can say, hey, what if I had 10% more smokers take the policy? What will happen to the distribution of claims that I have? So you can generate such scenarios and generate data, and from that estimate the distribution and make some analysis and do decision making. So that's what we call classic. It used to be called digital twin. It used to be called a variety of names. But if you get the model right, you should be able to create such scenarios and analyze.
Yeah. So help me us understand. Obviously, there is you have tremendous background in this space, having done a ton of work and research over at MIT, a number of different projects. We'll put some links to those in the show notes. People have been doing things around synthetic data for, disaster recovery, things like you said, for modeling. What's really evolved in this space that obviously, now with AI being a big deal, people are thinking about it more, but have there been any sort of big breakthroughs that are allowing people to be more flexible in saying, for example, like I start with, this real set of data of whatever size, and I can now do 10, 12, 15 different variations of it. Like what's evolving in the space to sort of bring this back to the forefront of being important for people?
One of the things that is evolved in this space is, technology-wise, what has evolved is generative modeling has evolved a lot. I think it has become more and more capable of building a model like this for a multi-table complex data set. So we focus a lot on relational and data warehouses kind of data, not necessarily language.
Sure.
So we invented the first generative model for relational databases. That technology has matured over the last few years in my group at MIT. So that has made this fully possible. So that's one thing. I think the bigger item that from the use case point of view, the bigger item is that I think a lot of software applications, we find a prominent use case of testing software applications. And a lot of these applications over the last decade have become data-driven. So what I mean by that is there's a lot of conditional logic inside the software that is dependent on what data it sees. Regardless of what application, they make conditions saying that if you see this in the data, if this particular type of demographic or this particular type of session or what have you, they make decisions within the software application. Now, to test those applications, you need the data. And that data in the past has been either generated by copying, masking, and anonymizing. That was one of the classic ways. Or it was generated using writing manual rules. By writing you almost maintained a script on the side, writing rules and creating the data, which is what they call synthetic data. And that became untenable because number of things that you have to add to that script just became way too many. Every release, you're adding more functionality, data-driven functionality, and you're you're adding a lot more to that script as well. So this comes in really handy because you can try to train a generative model on the database. Next to the database, you don't have to move the data around. And once you have that model, now you can create synthetic data from it just by just one prompt or one call to the model. You can create the data. So that's where we are seeing a lot of demand for it. Then the second demand where we are seeing a lot is training machine learning models. Most of the machine learning models the good ones are trying to predict an outcome that is of interest to the business, and usually that outcome is rare in the number of times it happens. So what happens is when machine learning models are trained on data like that, where you have only a few examples of that rare occurrence and a ton of examples when that did not happen, and you want to predict that rare occurrence, you end up overfitting. The machine learning model ends up overfitting to that data that it has seen. Adding synthetic data provides a lot of benefit in terms of reducing that overfit. So to give you an example, one of our customers was trying to predict from ServiceNow data. So they had ServiceNow database for their local sort of enterprise, for their local DevOps work. And they're trying to predict what change may cause an incident of priority P0 and P1, or major incidents. Now, the major incidents, thankfully, were just like 100, maybe less than 100, whereas the rest of the incidents that were not that major were like 80,000 or so. And the predictive model was not able to produce a good accuracy because it was overfitting to the data, the few examples it had. In that case, they added synthetic data to it. They learned a generative model on that database. They created the data. They added more synthetic examples for the major incidents. So just increase the size of that data, and then trained a machine learning model, and they were able to get a better predictive accuracy.
And how does the concept of bias fit in with something like that? I guess, what I mean by that is, I can absolutely see synthetic data being created, but if it's not created from a wide enough initial data set, then it seems like bias could creep in at scale over time. Is that a valid concern, or how would I think about something like that?
That's a valid concern. I think we sort of focus on how to subsample the data from the database. So your bias could be when you subsample to train this model, the generative model, it could come from that. So we provide the ability to do proper sampling. I mean, there's ways to overcome that. There's bias when inherently your data collection is biased. So that's an even more problematic situation, in which case I think a lot of downstream applications or usage of data also have measures to measure bias and be able to control for it. What happens is when you do that, you can actually sample from the model, focusing on reducing that bias in that application. So you can try to do that. The models allow you to create data that are of a particular demographic or a particular sort of category, so that you can reduce the bias in the application itself. So two things: if your data itself is good in the database, we provide functionality to sample it properly so that you don't create biased data to train this model. The second thing is, if your database itself is biased, in your application you can actually sample more data of one kind, of one category, to control for that bias.
And maybe I'll take it one step further then too. In addition to the bias, and I don't know what the term is, but how do we verify, if you will, or how do we verify the quality of all of that? And so take everyone maybe one step further, because I kind of think of this as you've got the generative AI. It's going to, you describe it a need. I need this kind of data set. It's going to return that. And then it will create this fake data set or synthetic data set. Well, how would an organization, if I'm doing this, how do they then turn around and verify that this data set that was created was of an acceptable level of quality? So I guess maybe not just the bias, but as well as was it quality data, and how do you validate that?
Great question. So we open source a library. I think it's probably the first. It's called Synthetic Data Metrics. So what it does is that if you give real data and synthetic data, it doesn't matter where the synthetic data was generated from, it measures a variety of metrics, saying that how similar are they statistically. And what is interesting is that you would have to balance that with two other measures. One of that is diagnostic. We call it diagnostic. So basically maintaining the format, the properties, the referential integrity. So those are must-haves when you generate synthetic data. The second property that we have to balance it with is privacy. So if you make it statistically really, really, really close to the real data, there is a chance you could leak privacy. You can leak private information. So as a result, you counterbalance that with some privacy measures, and those metrics also can be calculated by passing the real data and synthetic data. So we have three sort of metrics in that library. One is quality metrics, which are statistical measures of comparing those two data sets. Diagnostic measures, which compares if the properties are met, or certain basic properties that are must-haves, and privacy metrics that actually calculates the privacy for that. And then the enterprises can choose from, the trade-off points, because you can actually manage this generative model in a way that you can create multiple synthetic data sets. And as a result, you can actually see the metrics and choose the trade-off point. Do you want more data with high fidelity, high quality, but a little less privacy? Or do you want a lot of privacy, like you want to be able to have the data perfectly foolproof while forego some amount of quality?
Yeah, no, it makes sense. I'm curious as I'm thinking about this and sort of learning about it as you go. I mean, at some point, the ability to create this synthetic data feels, especially if you can, like you said, do things like say, hey, I'd like to essentially experiment or manipulate it if the model looked like this, 10% more in this direction or 15% more, with this sort of weighting to it. At what point does kind of creating synthetic data and essentially creating a model or training a model start to look like the same thing, in terms of the amount of time and resources it takes, or how much ability you have to kind of manipulate the weights and so forth? Like, do they start to look, the process of doing this kind of begin to look the same, or is there very, very different, kind of creating synthetic data and creating models, they just become very different things?
It's the creating synthetic data and models, they probably overlap significantly once you have trained the model, the generative model. I think the classical way of creating synthetic data was very manual. I think generative model, the other additional advantage, what it did was that it essentially automated that process. So you don't have to worry about, anything to write manually or anything. And the second thing is it gives you a very succinct representation of the data in terms of model parameters. So you can tweak those as well. So it looks a very different workflow when you try to interact with the generative model that's trained and create synthetic data from it, versus when you just go and write it everything from scratch and do things like that.
Yeah.
I don't know if that answered your question, but yeah.
No, it's helpful. I'm sort of my thought process went down the path of I can imagine that companies could potentially start thinking about, for example, like their competition, or think about a new market and go and create a model that they think looks like that, and then do scenario planning against it and other types of things. So
yes.
Yeah. Okay.
That's actually one of the very common use cases where you have launched a product and you had, like, let's say 1 million customers in US region. And now you launch the same product in Europe and you only had 10,000 customers. It's coming, but the rate at which you're getting is slower, but you have a lot more data at US. So what you can do is you can see if there is some overlapping patterns between the two populations. And also, if you have overlapping customers that are both lived in US and are also living in UK or traveling between both places, and use that generative model to augment the data, trying to do analysis for the UK or Europe region, right? That's a very popular use case where people try to augment the data for new launches or new places where you haven't yet got enough data yet, but you have from other places, you have some data to anchor on.
Gotcha.
Okay. That's really fascinating. I love that. One last topic before we close out for the day. Let's talk about resources a bit. Whenever I think of GenAI and specifically around any kind of training or fine-tuning, I immediately think about large amounts of hardware, right? Whether it's GPUs or, and certainly GPUs these days, they tend to have limited availability, right? And is that something that is true here? And also, is this something that is on-prem, or is it in cloud, or is it both? Or, tell me a little bit about the resources required and maybe the differences between using synthetic data and real world for something like this.
We created algorithms for especially this kind of data that does not require GPU. So we used very classical techniques, statistical techniques, but then did repurpose them or reinvented them, I guess, for relational tables. They're called probabilistic graphical models. So they can be trained on CPUs and much faster. They can be trained really fast on these CPU machines, classic off-the-shelf CPU machines. So as a result, what one of the customers actually, or many of them actually, compliment, saying that I think because it takes such a less compute power and it actually can train effectively and efficiently on large amounts of data, the number of applications that they can imagine for this generative model to be used for is huge, because otherwise it was a lot of expense and then it cut down the number of use cases they can use it for. So to answer your question, we are able to train on just CPUs alone, and GPUs are not required. To answer the second question, cloud on-prem. So it's on-prem and private cloud. So whatever cloud service provider that they're using, we can run the software there. They can run the software there, integrate with their data and run it. Or they can just run an on-prem cluster or compute or machine that they have. One of the important things here is that very early on, we made this call saying that it can't be a hosted, because it doesn't make sense for somebody to say, to protect your data, upload to us. And we are not a cloud provider, so it doesn't make sense for them to upload the data and then be able to get the generative model. So we provide our software so that they can install and run it in their environments.
Yeah, makes sense. Yeah, and I think that's maybe one of the undercovered or maybe under-discussed aspects of AI is people are kind of following, well, all the GPUs are in the cloud, so everything must happen in the cloud, and they sort of forget that so much of company data is still on-prem and kind of kept under lock and key. And so, yeah, that where do I do the processing? Where do I keep data? Where can I do synthetic data is really, really important. Before we wrap up, I want to ask real quick, because we didn't spend a lot of time on Data SIBO and how you guys deliver this. Real quick, if folks are interested in how you guys deliver synthetic data, what's the best way to engage with the company? What's sort of the typical engagement model? How would people reach out and work with your team? Because you guys have tremendous amount of experience in this space.
Yeah. So the first thing a lot of people do is use our source available software called the Synthetic Data Vault, which has a number of modeling techniques, generative modeling techniques for a variety of enterprise level data sets. And they train them, they install and train them on-prem without us even being involved at that stage. There's documentation available. It's picked up by sort of thousands of folks in the community. So the website is sdv.dev, like that's where all the resources are right now as well. So once they establish a use case and they find some success with it, then they reach out to us for SDV Enterprise version, where it allows them to scale to many tables, multiple tables, and a lot of cool enterprise features, multiple data types, and a lot of complexity as well in the enterprise data set. So it is able to address all of those, and they reach out to us to get SDV Enterprise subscription.
Fantastic.
Awesome.
Thank you.
Awesome.
That's really great to hear. So, go ahead.
Yeah, go ahead.
No, I was just going to say, so that's a really good summary of everything, and thank you for kind of taking us through all of that today. So, I think we'll close it out there, Brian.
Yeah, no, this has been really, really helpful, and it helps, at least in my mind, kind of close a gap, or at least fill in a hole in terms of thinking about how our team's going to sort of manage this challenge of security. Where's my data? If my data is not perfect for what somebody has in mind as to what's possible with some of these AI models, this feels like it fills in so many spaces, or at least it starts to unlock so many spaces. So Kalyan, thank you so much for the time today, for the insights. We really appreciate it. And folks, as we mentioned, him and his team have a ton of background, both obviously what they've been doing with Data SIBO, but the work they had done previously and still continue to do with MIT and the labs over there. So very, very excited to have the opportunity to speak with you today. So thank you for the time. Aaron, you want to wrap us up and take us home?
Yeah, absolutely. So first of all, everyone out there, thank you very much for listening. We certainly appreciate it. And if you enjoy the show, please tell a friend. And also, please leave us a review if it's possible, wherever you get your podcasts. For Brian and myself, I'm going to close this out for this week. And you can follow us. Of course, all the links are in the show notes, as always, and on the website. And we thank everyone for their time. And we will talk to everyone next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.